So I've got a lot of jobs back here. And if I look down through the listings, I can see some information about the types of systems that different companies are working with. So here's an example here. I happen to know that Cybercoders is a headhunter, so it's unlikely we'll find the company name here, but we can pop this open. You can see that they are looking for somebody who has experience with Windows, Cisco, Citrix, and healthcare. So it's a healthcare company. It's using Windows, and they're also using Cisco probably for their network hardware, and they are using Citrix for probably some sort of virtualization solution. So that's a lot of information that we now know about this company. And if you were to plug in a particular company as well as a job like systems administrator, you could turn up all sorts of information about the types of infrastructure that they are using. This is a company called Akibia, and they're looking for somebody who does Unix, Apache, and Tomcat. So there's another company that's provided information about the types of systems that they use. So again, you can see Monster is a very good resource for finding information about the types of systems and software that companies are using. And the reason for that is if you're looking to hire somebody, you're going to use a site like Monster, and you need to post the types of job requirements and the skills required. And so if you start looking around for a particular company and you look for the right jobs, you're going to be able to find out the types of systems and software that they are using in-house. Often, in addition to the Apply Here button, you may see an email address at the bottom, and sometimes it's something like HR or jobs or careers, but occasionally you'll see an actual recruiter's email address, and that can provide you some information about not only that user or that person, and you may be able to use that down the road in some sort of social engineering attack where you can pretend to be that person, where you have their name and also the position that they hold. You can also make some determinations probably about email addresses for other people in the company, and you may be able to use those as well. If you go to LinkedIn, you're going to find the same sort of thing where people who have previously worked at that company are going to list the types of experience that they have, and you may be able to figure out, again, the types of systems and infrastructure that that company is using. Facebook or other social networking mechanisms like Twitter, for example, you could do some searching for companies or users that you have found in other ways and see if you can find some information about things that they have posted about the things that they do at their job, the types of systems that they work with, or sometimes people will slip and post things like, we had a major outage because we were off on Apache. It's really not a good idea to do that sort of thing, but sometimes people make mistakes and they don't get caught. So there's all sorts of resources available on the web to find out the types of systems and software, as well as information about users and people within different companies, and you can use that to your advantage when you start looking to exploit vulnerabilities down the road. In this lesson, we're going to be going over the use of Whois, a utility that is used to query the various regional internet registries to store information about domain names and IP addresses, and there are 5 regional internet registries. First, there's ARIN, which is responsible for North America, so that would be the US and Canada. And then we have LACNIC, which is responsible for Latin America and portions of the Caribbean. RIPE, that's responsible for Europe, the Middle East, and Central Asia. AFRINIC, which is responsible for Africa. And finally, we have APNIC, which is responsible for the Asia-Pacific Rim. So that's the regional internet registries, and as I said, Whois is responsible for querying information from the various regional internet registries, and you can use Whois to get information about who owns a particular IP address. So, for example, I could do whois, and I'm just going to make up an address here. And whois tells me that actually belongs to IBM. You can find out pretty quickly who owns particular IP addresses and who's responsible for them. And from that information, you can get email addresses that belong to a particular company. This one has an email address for the tech contact of ipreg@us.ibm.com. So that's just doing a whois query. I can specify which whois registry I want to query. So different IP addresses and different information belong in the different regional internet registries, of course. So if I wanted to go to a particular database, I would use the -h flag. So I could do whois.aaron.net and remember the IP address. And I'm going to query that again. And of course, I get the same information back because I went to where it's actually stored. So I can query the regional internet registries directly using the -h flag, and the different registries, of course, would use whois.whatever for their whois server. So in this case, it would be whois.aaron.net. So I can get information about domains as well. So I can query infiniteskills.com, and I can find out that this is Infinite Skills. There's an administrative contact and a technical contact, and you can see the different domain servers. So the servers that would have authoritative information about the DNS entries for that particular domain. You can also see other information like when the record was created for that particular domain. This goes back to 2007. Now, I could also find information where I may not know specifically what I'm looking for. So if I just did whois foo, I would get a whole lot of systems and domain names that existed with that particular string in it. So you can see it actually aborted after 50 records were found because there's a lot of different systems out there that have foo as part of the name of the system. So the regional registries, in addition to storing information about IP addresses and domain names, sometimes will store information about particular host names. And there may be other reasons why you would store a host name or particular information about a host name or a system name within one of the RIRs. Now, if I wanted to look up something specifically once I had found that, I could now do a lookup on whoisfoo.bar, and it says we don't actually know what that is. Not surprising. I could also do something like this where I'd get more detailed information about all of the things that it turned up. So if I did a whois equals foo, I've got all of these bits of information. So here, for example, is foo.net. The registrar is Network Solutions. And I've got a couple of name servers here, and the creation date and the expiration date. Same thing here with foo.com. So I could scroll up and find more detailed information about the 50 specific things, just in case you wanted to get more information to figure out which entity you were actually looking for. You could use the equals and help you narrow down what you were really looking for. So I'm using whois as a command line utility here. There are other ways of accessing whois, and this command line utility is available on Unix-like operating systems. Right now, though, I'm going to show you a web interface at geektools.com, and Geek Tools has a handful of tools that are useful for system administrator kind of uses, and in this case, for our ethical hacking uses. So I'm going to go to the whois site. They've got a little CAPTCHA thing there. And now I'm going to say I want to look up infiniteskills.com. And it's the same thing as I had before. It's just I've got a web interface. So you could do this from like your phone or a tablet or some other device where you may not have command line access. As long as you've got a web browser, you can look up all of this information. Now, if you're running on Windows and you like the command line access for maybe programmatic reasons, you want to script a bunch of things or something like that, or you just like typing, there is a Whois utility for Windows. So if you go to Windows sysinternals, you can download it. So it provides the same functionality as the one that you can get on Unix-like systems. So that's information about how you would look up details about maybe your target and get more information about them using Whois. In this lesson, we're going to be talking about using DNS to extract information. DNS is the domain name service, and the domain name service exists because it's easier to remember things that look more like words than it is to remember a series of numbers. So nobody's going to walk around remembering IP addresses, so we have to have mnemonics, which means we have to have ways of referring to systems and hosts and servers on the internet without referring to them by their IP address. So we need to use something called the domain name system, or DNS, in order to do that translation from hostname to IP address and from IP address to hostname. So I'm going to show you a few different ways to extract information from DNS. The first little utility I'm going to show you runs on just about all systems that run TCP/IP. It certainly runs on Windows and Unix. It's called NSLookup. So I'm in Windows here. I'm going to run NSLookup, and you can see I've started up and it's telling me what my DNS server is. As a default, I can actually change that, and I'm going to change that to 4.2.2.1. And now I can just type in a host name here, and it's telling me that this host name, www.infiniteskills.com, is actually an alias for infiniteskills.com, and that has the address 76.12.59.46. Something else I can do with NSLookup is look up different types of records in DNS. In DNS, there are several different types of records. One of them happens to be the A record, which is what I just looked up here. So the A record translates a host name to an IP address. A pointer record, or PTR record, does the reverse, which is IP address to host name. I can also do MX, which is the mail exchanger record. That's another type that I can look up. So I can look up the mail exchanger records for the domain infiniteskills.com, and you can see here I've got several MX records with different preferences, and the preference indicates the hierarchical order in which these different mail exchangers should be used. I can also do set type equals SOA, and if I type infinite skills again, I get the start of authority record. So I've got the primary name server, the responsible mail address, the serial number, the refresh rate, retry, expire, and the default time to live. So that's all information about the domain Infinite Skills, and that's all stored in a record called the SOA record, or the start of authority record. Now, another tool that you can use is more of a Unix thing, and that's something called host, where I can just do infiniteskills.com. And host will just do a very quick and simple lookup without a lot of frills and without a lot of extraneous information or a lot of other stuff that you've got to read through. It says here that www.infiniteskills.com is an alias for infiniteskills.com, shows me the IP address, and because it's a reference to the domain name as host name, it also gives me the mail exchanger records. So that's the host command, and as I said, that runs on Unix. I could do host 4.2.2.1, and that will do a reverse lookup as well. So I can look up things very quickly with host. Now, there's another tool that I can use if I want to get into a lot of detail. I can use dig, and I can dig infiniteskills.com. And that tells me that infiniteskills.com has an IP address, and it actually tells you the record type that it's got. You see in A there, tells me it's an A record, and that's 76.12.59.46. It also gives me information about how long the query took in the server that it used to do that. So I could change the server that I'm going to and do the same query. And you can see I did a dig at 4.2.2.1. That tells Dig that I want to use that IP address as my server. When it goes and does the query, it should query that server rather than the default server. So it went out to 4.2.2.1 and queried for that particular piece of information. And you can see at the bottom again, I've got the server and how long it took. In this case, it took 50 milliseconds, and the message size was 52 bytes. Same thing here as with NSLOOKUP. I could do digmx, and that's going to give me the MX record. I can do dig-SOA. I could do dig-SRV. So I can look up any of the record types using Dig. Dig has a lot of information about the question, the authority, which server it's using, how long it took, and the message size that it came back with. I could do a dig PTR 174.118.14.72. It tells me that particular address doesn't actually have a host name attached to it. It does tell me the root server that it went to in order to look up that particular information. It's got some information about the start of authority record for that particular server. Now, something else I can do with Dig, and this doesn't work as often as it used to in the past. Used to be you could list servers from the domain. So if I were to use NSLOOKUP, like I could do ls, and that would list the servers for a particular domain. I could dump the entire DNS table. Most people don't allow things called domain transfers, but it's often worthwhile just to give it a try. What I would do would be dig AXFR, which means I want to do a transfer of A records, and it's basically going to list the host names if it works. In this case, it's not going to work because they don't allow transfers. You can see transfer failed. But since it's such a quick little test, it's worthwhile doing the dig AXFR just to see if you can get the list of domain names and see whether you can get that list and provide some jumping off points for places that you can go looking. So that's information about how to use DNS and the various DNS-related tools to extract information about your target. In this lesson, we're going to be going over how to find network ranges. So you've got an engagement that you're working on, and you only know the domain name, and you don't know much beyond that, and you're expected to figure out where everything is and what everything is. So how do you go about doing that? Well, you use some of the tools that we either have been talking about or will soon be talking about in more detail. And the first thing I'm going to do is I'm going to use the domain name infiniteskills.com, and I'm going to look up Infinite Skills, and I've got an IP address back here. So that's just an IP address. I don't know who that IP address belongs to. And I also don't know how big the network range or network block is that's associated with that. So I'm going to do a whois, and I'm going to look up with Aaron, who owns that IP address. And I can see it's owned by Host My Site, and the network block or network range is 76.12.0.0 all the way through 76.12.255.255. Host My Site, I am going to guess, is a hosting provider. It would be out of scope to look at any of those other addresses unless I can find some evidence that Infinite Skills has a presence on a different address than the one I have located by looking up that particular host name. So I've got one address here that I can look at. Let's take a look at the website, because that may be a different address. www.infiniteskills.com is an alias for infiniteskills.com, which I've already looked up. What I'm seeing here is all the mail that's being handled. If I didn't have that, I could do digmx infiniteskills.com, and I could get back all of the mail handlers. In this case, their mail is being handled by Google. If it weren't being handled by Google, let's say this was a different address, I could do a host here. and get the IP address back. Now I've got an IP address, and now I'm going to do a whois again, and it's going to tell me that that's Google. Not particularly surprising. The other thing you can do is to check for different host names. Since I'm assuming DNS probably doesn't allow zone transfers since most DNS servers don't anymore, although they used to, you may have to start guessing. So I could do something like host webmail.infiniteskills.com. And this is completely guessing, and it may not actually return something. In this case, it doesn't. I could also guess something like vpn.infiniteskills.com. And I've got nothing there. But you could keep going, remote, mail, any other different type of host name that you can think of that may be serving up some additional content. Any host name that you may be able to run across using a Google search. You find the IP address, you figure out who it belongs to, and you just keep going, and you start narrowing down the field of what IP addresses belong to what entities and what IP addresses are relevant to the one that you are working on. The other thing that you can do sometimes is, if I did a whoisinfiniteskills.com, sometimes what you will get in contact information, you may find that their email address refers to a different domain name, and you can use the same techniques that I've just demonstrated here against that domain name in order to figure out whether it's related to the target that you've been given. And if it is, you start chugging away with finding all of the information that you can about that. So you're going to want to use a lot of DNS information to look for these network ranges. You also are going to need to use the Whois databases and the internet registries. A lot of it takes a lot of guesswork and just making inferences. So if you see something that looks like it may be related, start looking it up and chasing down the lead and see where it goes. This can be a time-consuming task, but you want to make sure that you get all of the targets that you can if you haven't been provided them. And again, you always want to make sure that you have the scope clearly in mind and clearly agreed to, even if they don't give you a set of information that they want you to track down, IP addresses or domain names. They should always give you exclusions if they've got any. So that's how you would go about looking for network ranges for particular engagements. This lesson will be talking about Google hacking. And no, I'm not talking about breaking into Google to steal information. I'm talking about making use of specific keywords that Google uses to get the most out of the queries that you submit. So, for example, a pretty basic one is the use of quotations. You quote things in order to use specific phrases, otherwise Google will find pages that have instances of all of those words rather than the words specifically together in a particular order. So I'm going to pull this query up, and this should show a list of sites that have pages where there's a directory listing allowed on the website. And here you see index of /, which is what I use. That's a directory listing for Ubuntu. We can also use another simple one. The plus sign says you have to find this word in your query. It's critical. And here's a list of different sites that have this particular set of words in it. So index of /, and we want to make sure we get the PASSWD or password file. Google has defined a number of keywords, for example, this one, and that gives us a set of answers that has a file type config in it. So you can see the second one down, web.config, and the third one down, web.config. So the file type is config there. We can also use a query that looks for a set of words just in the title. So I'm going to look for sensitive in the title. And you can see a number of responses here. Another thing I can use is file type. As we did above, I can add that into this one. and I want to look for Word documents where the title says sensitive. And here's a set of responses for that. You can see the doc indicator on the Google response that we found some Word documents. I can look for cite. And you can see here, the first one, other than the definition, is a PDF that's a questionnaire for non-sensitive positions, and that's in the Navy, so ncis.navy.mil, because we looked for mil as the site, and you can get more specific than that. We can also look for keywords in the URL. I want to look for www.root, which is a pretty common directory, and we've found a handful of responses here. So that's all in the URL, which would be the address that's in the address bar up above. I can look for in title, which is slightly different from all in title. And I can look for ext, which is similar to the file type. We're looking for file extensions. We could use ext.js, which would be a JavaScript file, and you can see a number of JavaScript files here that come up in response. And another one we can use, this one is maybe a little bit more obvious. What this says is we're looking for the words in this query in the text of the page. So that's a number of keywords that you can use to look for information in Google and find some very specific responses. In this lesson, we'll be going into some more detail about the various things you can find using Google hacking techniques. While Google hacking techniques are really useful for just general searching in Google, they're also really useful for penetration testers or ethical hackers. You can narrow down information that you get from Google so you get a specific list of systems that may be vulnerable. So we can do things like look for error pages. If I do in title error, I'm going to get a whole bunch of information here, various documentation pages about different vendors and the errors that they support. So here's one, for example, at docs.oracle.com about a Java error. But if you know something more specific, we may be able to get errors here about MySQL. And again, you're going to get a lot of forums and documentation pages unless you do something like -forum or -manual. And the minus says, leave these things out of my responses that you show me. So we can get into a lot of detail here about the types of things that we're looking for. And it can take a lot of work to actually get the specific pages that you're looking for after you've narrowed down all of the extraneous information from things like documentation and forums and discussions and that sort of thing. We can look for things like version numbers. For example, you may be able to get Apache servers that are running some version of 2. And again, we're getting a lot of documentation pages. And we can narrow down that focus a little bit more with various other queries. Sometimes you can get information about people's systems. We're going to look for directory listings, which is why I look for index of. And I'm going to look for a bash history file. And bash history will show a list of commands that somebody has been running. So here's a page right here, and here's the bash history. So we can look at another page here, and you can see there's a number of them where people have given their file listings to their web server and made them available for whatever reason. Sometimes they don't realize they're doing it. Sometimes it's for specific purposes. But you can get all sorts of information about things that people may not actually want you to see. We can also look for things like specific servers. So we can look for powered by shout stats, and then we're going to look for the words hourly and daily, and that will give us pages where statistics from Shoutcast servers are available. And we may want to do something like drop off Google so that we avoid places where it references Google hacking. So here's a page right here for a Shoutcast server. And we've got a particular server that's available. You can see it's at this address here. We can also look for things like outdated web servers. So I'm looking for Microsoft IIS 5.0, and you see the server at. I want to find this particular phrase because it's going to indicate something that the server generated with its version number, and there will be an IP address or a host name after the server at piece. And again, we get the Google things, so we can drop those off. And here's an example. It's actually an index page, and there's the server that it's available at. So there's a system running a very old version of Microsoft IIS. You can also look for things like specific web applications and vulnerable data in those web applications. In this case, I'm going to look for information about Joomla, which is a web application, and I'm going to look for an index page with a file listing that says joomla1.txt, index of / right off the bat. Here's a couple of them actually. And you can see this particular file has a lot of information in it, variables, and probably there's a lot of details about maybe passwords and host names on the system. So as you can see, using Google hacking, we can turn up all sorts of information in a very targeted way. This lesson will be talking about the Google Hacking Database. Several years ago, a guy by the name of Johnny Long put this Google Hacking Database together to begin to compile a list of searches that would bring up interesting information. Johnny has also written a couple of books on Google hacking. So we're at the Google Hacking Database website here, and you can see them talk about Google Dorks, and there is a list here of the latest Google hacking entries. And they also have a number of categories that you can look through to find some specific things that you may be interested in. Of course, you can also search specific information that you may be looking for with regards to a specific product, for example, like here's one on Joomla. There's also information about files containing usernames. This is always interesting. You don't necessarily get the passwords here, but a username can sometimes get you a foothold into some password cracking attempts. You can do some brute force checking, and you can see here it talks about the type of search it is and what it reveals, and you can just click here on the Google search and it will actually bring up Google with the list of responses that Google generates. So let's look at this one here. The file type is log, and the username is putty, and this is information about an SSH client, and let's see what we can bring up here. So here's a putty log. You can see they're using username ec2-user, so they're logging into an Amazon Linux system, which it says right here in the middle, although EC2 is the product that Amazon uses for some of their cloud computing. And if we continue to scroll down, there's a lot of interesting information in here. So somehow somebody's got a putty log that has logged a lot of information, and they've just got it up on a website. So looking through a little bit more, we can see a number of other things. There's vulnerable servers, which can bring up interesting information about specific server types. Here's one here, find servers vulnerable to the CVE 2007-5423 exploit. So you can find servers that are vulnerable to specific exploits. If you were looking to see if your client, for example, may have a server that's vulnerable, you may want to do that type of search. Error messages are really interesting. They often provide, as this says here, way too much information. And let's just bring up one of these searches just for fun. We're going to look for some PHP data. And as we've mentioned before, sometimes you're not going to always get everything that's a hit. Sometimes it requires a little bit more. And we have some information on this website. There's a warning about this particular PHP page. And we've also got information here about a directory and a path on the system that may provide us some information. There are a number of other categories here. Files containing passwords, files containing juicy information, network or vulnerability data. Various online devices are interesting because you may end up being able to find things like cameras, or in this case, here's a Beyond TV. You can get surveillance video, more or less what this one here is, Spectra IV IP. And here's a website that's got a camera. And in this case, it's taking some time for the video to load, or there may be a problem with the QuickTime stream. I can, however, take a snapshot and then open it up. And there's the snapshot, so you can see that the video is actually working. So a number of categories that they've classified things into: advisories and vulnerabilities, pages containing login portals. But what this really has is a list of queries that you may be able to use as you're going through a penetration test. So the Google Hacking Database, definitely a website to put into your bookmarks and check in with on a regular basis as you're working with your clients and doing ethical hacking and penetration testing. In this lesson, we're going to be talking about the history of TCP/IP, the network that eventually morphed into the thing that we now call the Internet began in 1969, and it spun out of this government organization called ARPA, which was the Advanced Research Projects Agency. They had an idea to create a computer network that was resilient to certain types of military attacks. And the idea was to have this network that would survive certain types of war and warlike conditions. So ARPA sent out this request for proposals, and BBN, which is Bolt, Beranek, and Newman, and they were previously an acoustical consulting company. They won the contract to build what was called the ARPANET. The first connection was in 1969. So that's where we get the idea that the Internet began in 1969. The Internet, as we call it now, didn't really begin in 1969, but the ARPANET did, and the ARPANET has a long history that goes through the NSFNet in the 1980s after the ARPANET was sort of decommissioned, and a lot of other networks were folded into this thing called the NSFNet that then turned into what we now call the Internet once a lot of other networks were connected into it. First protocols on the ARPANET. Initially, there was the 1822 protocol, which was the very first protocol defining communications on the ARPANET, and it was called the 1822 protocol because of BBN Report 1822, which described how it worked. Shortly after that, there was this thing called the Network Control Program. And the Network Control Program consisted of ARPANET host-to-host protocol and an initial connection protocol. Now, there's certainly not a direct correlation or analogy here, but if you want to think about it in a particular way, you could say that the ARPANET host-to-host protocol is kind of like UDP, and the initial connection protocol is kind of like TCP. So the host-to-host protocol provided a unidirectional flow-controlled stream between hosts, which sounds a little bit like UDP. And the ICP provided a bidirectional pair of streams between two hosts. Again, these aren't perfect analogies, but the host-to-host protocol is a little bit like UDP, and the ICP is a little bit like TCP. Now, the first router was called an interface message processor, and that was developed by BBN. It was actually a ruggedized Honeywell computer that had special interfaces and software. So the first router wasn't a ground-up built piece of hardware. It was actually an existing piece of hardware that was specially purposed for this particular application. So Honeywell had this computer that